There we are.
Fine. Well, in the previous section, we looked at solutions, and really, I tried to sort of bundle those up in terms of inbound solutions around compulsion, threats, and big sticks. Let's think now, and much of that, of course, is to do with the EU and with government bodies and so forth. Let's think now around this issue of how we can proactively deliver these solutions from business supply chains, which is really accelerated by, if you like, either enlightened or some would say commercial self-interest, because effectively that's the so-called capitalist system. It's a very efficient allocator of resources, provided it's constrained appropriately, and no doubt the same philosophy would apply in terms of the environmental challenges. And I'm reasonably hopeful in this area, because only in the last 12 months you've got large brands like PepsiCo, Coca-Cola, Associated British Foods, I think, and a number of big UK brands have been now committing to low carbon systems. They can't deliver them immediately because of the points I was making earlier about the embedded investment, but nevertheless the signs are there of substantial move. And this is driven by self-enlightened economics. It's driven by the fact that market share is in part influenced by people's attitudes to the social responsibility that brands are undertaking. Most notably, companies like Marks and Spencer's have exploited that, and exploited is maybe the wrong word, but they've nevertheless identified it as a key issue in terms of customer retention. The technologies that are going to come out of this are all underpinned by this philosophy that the so-called footprint of the brand is going to be minimised, and therefore they're investigating now right the way back to raw material production, conversion, packaging, in terms of plastic versus cardboard and so on, distribution and logistics, retail activities. These big brands are now breaking down their supply chains, not just to drive out financial costs, but to drive out environmental costs, whether it's child labour, whether it's carbon dioxide emissions, or whatever. And sometimes at critical points, that means that you start injecting technology. That technology may be looking at, for instance, the introduction of biochar into the food process chain. It's a much vaunted solution, but there are issues. I know the Aztecs are believed to have found it very effective, but in reality, if you put anything into a biochar process at low temperature, and it contains heavy metals, then those heavy metals, those toluenes and those long-chain hydrocarbons that cause a problem in the incineration process in terms of chimney emissions are sitting there in the biochar as well. So all is not simple.
Aztecs didn't have that problem, apparently.
And Aztecs never had that problem because they never had fertilizers, they never had ammonia, they never had, well, they had natural ammonia, but not chemical ammonia. So effectively, technology may be cladding on buildings, it could be photovoltaics, it could be combined heat and power systems, it could be LED lighting. In the case of supermarkets, they've identified massive issues around cooling, refrigeration systems, which in 20 years ago, most of our food was either ambient or deep frozen. It's invidious to go through all these technology issues, but CO2 absorption processes as plastics, as membranes, and of course in the waste context, the standardization. So a lot of supply chains in the food area have insisted on biodegradability for packaging as well as the food, because not all food is sold, and you don't want to be messing around with multiple mixtures and compounds that make them unrecyclable at the end of the process. So we traditionally have a strong track record. Information technology is going to play a part in terms of the speed of creating these understandings, both across supply chains and indeed right out into the customer base. I think that there's a lot of innovative work going around the energy area with seaweed harvesting, algae, the use of algae not as an algal bloom, But actually what algal blooms are, of course, they're soaking up the oxygen, but they're also then creating a carbon-based material. Now, that means that actually they're both a problem and an opportunity. So not everybody would necessarily agree that this is a natural process, and of course what we're doing is gradually industrializing our world so that perhaps in 200, 300 years it will be a human, it'll be one single giant spaceship that is on a fixed trajectory that will be there, entirely subservient to the needs of our species. Now, I'm not going to comment on whether that's a good thing or not, but I'm reasonably confident that the path to that route is likely to be well and truly laid through the economics of supply chains, through big brands, and through our capability for innovation. Those innovations in technology areas could come in terms of mechanical engineering, biochemical engineering, thermal conversion efficiencies, waste to hydrogen through the use of membranes, and equally, as the demand for scrap resources and wastes, whether that's as a gas, as CO2, or as plastic that's just floating around in the oceans, as the value of those materials rise, then of course you get the economic triggers to go out and harvest that material. And indeed one of the points that came out of the Hawaii conference that I made is that actually the price of plastic now is on a par with, or maybe even in excess of, the price per tonne that fishermen get for fish. So maybe we'll have fishermen out in the oceans fishing for plastic in 30, 40 years, and that plastic will be reprocessed back through energy conversion processes to deliver transport fuels, heat, electricity to the supply chains at ports and harbours where fishing fleets can dispose of that material for more beneficial use. So this is about blue sky thinking, it's about horizontal movement, innovation, and it's about process innovation as well as technological innovation. On the whole, though, we can be reasonably optimistic.
But also, I mean, just thinking of the harvesting plastic, there's actually, there can be economic benefits, not only in actual necessity to take carbon dioxide out of the air, not just through nature, but through mimicking nature through various technologies. And then,
yes,
for example, creating calcium carbonate, which can be apparently used as aggregate or even possibly some form of cement. So, that's an early stage of development at the moment,
yes,
in California and so on. But and the National Institute of Physics, I think, is doing a project with them. So, any comments on that sort of thing?
Well, yeah, biomimicry is, we've ignored that really since 1800s because we just didn't have the science. I think that clearly as you become very well aware of the depletion of the rainforest and so on, there's this sudden enforced pause because we're recognising not only are there materials out there that can far more effectively be applied in the pharmaceutical industry, but also we can mimic these processes and accelerate them. Again, I'm not necessarily a believer that we seem to be on a treadmill and we're trying to run faster and faster and faster up a steeper slope.
Yeah.
But leaving that to one side, the fact is that natural systems have evolved over millennia and they will continue to do so. And by and large, what we've got to do is to take those systems, industrialize them and accelerate them.
Yeah.
The fact is that our planet is one giant chemistry set.
So
a
reducing
holistic approach to that will be considerably helpful.
Because actually this fits in with the other session we had, I had with another colleague on climate, where he stresses the need to take carbon out of the air as well as to stop emissions and capture carbon before it is emitted.
Yes.
So that is actually all in the area of actually working with nature and trying to redress the imbalances in nature, perhaps caused by mainly human systems.
Two points on that. In terms of numbers, first of all, I think the numbers are pretty horrendous. We're looking at 450 million tonnes of CO2 equivalent emissions in the UK. Now that means that for you and I, 14 tonnes of sequestration. And if you just think about that, in the work that we did on the Biff Award mass balances, the Forestry Commission estimates that I had were that the entire tree mass of the UK net each year, even with massive planting programmes, is only of the order of 1 million tonnes of carbon, about 3.5 million tonnes of CO2. So if you just imagine from our experience in the UK, and you say, well, we've got to actually have 100, for every tree that you see today, you need at least 100 more planted every year, year after year after year. So the numbers are big. The second thing is that I think we've fallen into a bit of a hole because the environmentalists, and I count myself one with a small e, but some have tried to urge this distinction between short cycle carbon, if you like, planting trees as an offset, and long cycle carbon, which from an oil well or a coal mine. To me, CO2 is the enemy. The fact that a tonne of CO2 emissions comes from a wood burning power station doesn't make it any more better than a tonne of CO2 from an oil-fired station. I think that, and in the current rate of technology, wood-burning power stations are not sensible, or they're not as straightforward as one might think.
That's very helpful, Pete. Thank you.